Okay, next we're going to add and subtract fractions. So this is where it gets a little trickier. It says perform the operation and simplify the answer fully. 11/15 plus 1/6. So when we are adding and subtracting fractions, what did we have? We had 11/16 plus, let's see here. 11/15 plus 1/6. Okay, so in order to be able to add and subtract fractions, we have to know they have to be equivalent pieces, right? Otherwise, it's really hard for us to think about. And that kind of makes sense, if you're trying to give out slices of pizza, you want to make sure everybody's getting an even amount, so you need to have equivalent slices of pizza, right? So this pizza is sliced into 15 pieces, this one's sliced into 6 pieces. So if you're giving out slices of this pizza, people are going to get quite a bit more than handing out slices of the first pizza, which they're going to be quite a bit smaller slices, right? So we got to make sure everything's sliced into the same slice size pizza slices. So in order to do that, we have to have a common denominator. And there's a couple of different ways that you can go about finding a common denominator. Right, so you could look at your multiples of 15, which are 15, 30, 45, what else? 60, then 75, 90, 105, and so on, and it continues on. And then you could look at your multiples of 6, right, which we know, hey, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30, 6 times 6 is 36, 6 times 7 is 42, right, and so on. And at this point, you may already see, hey, I've got a common number right here, 30, right? So in order to create a denominator of 30, okay, I'm going to multiply 15 by 2 over 2. I'm allowed to do that because I can multiply anything by 1. I can multiply by 1 as much as I want. And 2 over 2 is just equal to 1. So that gives me 2 times 11, which is 22. 2 times 15 is 30. And I know 11/15 and 22 over 30 are actually equivalent fractions. And then same thing with my 1/6. I need a denominator of 30. And in order to get that, I had to multiply 6 by 1, 2, 3, 4, 5. So if I'm not allowed to multiply by 5, but I am allowed to multiply by 1. And I know 5 over 5 is 1. So 1 times 5 is 5. And 6 times 5 is 30. So 5/30 is equivalent to this fraction of 1/6. And now I have a common denominator, so I can just add my numerators, right? So 22 plus 5 gives me 27 over 30. Sorry, my mouse got away from me there. Here, let me see if I can correct that so it's easier to read. 27 over 30. Okay, now at this point, I want to double check and see, can I reduce this at all? 27 over 30, I feel pretty confident in saying this can reduce. I know my divisibility rules, and if I add 2 and 7, I get 9, which divides by 3. 3 and 0 gives me 3. That also divides by 3. So I know at a minimum, both of these numbers are going to divide by 3, right? 3 times 9 and 3 times 10. Right, so 3 over 3 is 1, which leaves me with 9/10. Again, my mouse is acting up. Sorry about that. Okay, so my final answer, my most reduced answer is going to be 9/10. All right, let's go ahead and type this in. 9 divided by 10. Let's see if Delta Math likes it, and they do. All right, and they show us the same method of looking for the least common multiple. Okay, that's going to be the easiest way. And then they show us simplifying the fraction just like we did, okay, to get our 9/10. Let's see here. Let's do one more. Okay, so another way that you can do this problem, I'll show you sort of the longer way. So we've got 5/12 and 1/15. blank. Great. Okay, so we've got 5/12 and 1/15. So if you're not loving the finding the least common multiple method, the one way that you can do that works every single time is taking your denominators and just multiplying them by each other, right? So if I do 12 times 15 here, let me see, 12 times 15, that's going to give me 180. Okay, so that tells me that my new denominator is going to be 180 for both of my fractions. I know at the very least, even if I can't find a least common multiple, I can always just multiply my two fractions together to get that common denominator. So that means that, hey, I multiplied my first fraction by 15, and if I do it to the bottom, I have to do it to the top, so I'm technically multiplying by 1. And 5 times 15 gives me 75. So I have 75 over 180. And then I'm going to do the same thing with my second fraction, except I'm multiplying that 15 by 12. And if I do it to the denominator, I have to also do it to the numerator. Oops, sorry. So that I'm technically multiplying by 1, right? And 1 times 12 is 12. So now I have a common denominator. I can just add my numerators. So that gives me 75 plus 12 over 180. And let's see here, 75 plus 12, let's see, that gives me 87 over 180. And I think I already see divisibility by 3 in both of those numbers. So this is the problem with doing adding your fractions by multiplying the denominators, is that you usually get a very large fraction that you have to reduce. So if you're not taking care to keep your numbers small from the beginning, you end up with large numbers and you have to do a lot of reducing at the end. So 87, I know that divides by 3. Let me see here. 87 divides by 3. That gives me 29 over 180 also divides by 3 to give me 60. Oh, sorry, my mouse again. To give me 60. And let's see here, 29 and 60. I think 29 is prime. Yeah, so I think that that would be our most reduced fraction. Okay, so 29 over 60. So let's go ahead and type that in, see what Delta Math says. Enter, enter. Yes, okay, cool. They liked it, and they kind of walk us through. Same deal. Here they're looking for the least common multiple, and if you did it this way, you wouldn't have had to reduce at the end. You would have just gotten the 29 over 60. All right, so that's adding and subtracting fractions. Well, really, we only did an adding problem. Let's see. Subtracting is not any different. The only difference is instead of adding the numerators, you would subtract the numerators, but you still have to go about finding a common denominator for subtraction, just like you would for an addition problem.